Hello and welcome to a short introduction of our position paper, Embracing Negative Results in Machine Learning. Our position is, we argue that machine learning research is at a point where it should encourage or even welcome the publication of more negative results. Now, if you're a machine learning researcher, you're probably somewhat familiar with negative results from your own empirical machine learning research. That's exactly why we think it's such an important topic. It touches all of us, and we think it could help recalibrate the empirical machine learning research community where leaderboardism has grown somewhat rampant over the last few years. That's why in our paper, as well as this short presentation, we first asked the question, what actually is a negative result? We then asked the question, should we care about them? We also examined the state of the art with respect to negative results in the machine learning research community. And finally, we kind of shed a light on the way forward. We give some recommendations, some practical steps on how to better embrace negative results in empirical machine learning. To start off from common ground, let's have a quick look at what we believe constitutes a negative result in empirical machine learning research. The usual null hypothesis that we look at in this scenario is that a proposed or examined method does not actually beat the state of the art. And if we're not able to reject that null hypothesis, we get a negative result. And if we're able to reject that null hypothesis, we have a positive result. Now there's two flavors of negative results that we want to have a quick look at. The first one is existing method negative results, which is sort of your failure modes of existing methods, the state of the art, your replication studies that don't back up previous experiments. And these are sometimes published. Famous examples are vanishing gradients or adversarial examples. And then the other one, probably what your mind goes to when you hear negative results, it's also what our mind goes to, and that's why a lot of our papers about them are novel method negative results. That's a scenario where you as a researcher come up with a new method, a new algorithm that you think is interesting and a cool new technique, but it does not actually beat the state of the art. And these are very rarely published, probably not at all, and we do believe that some of them do deserve to be published. We have already alluded to leaderboardism being a problem in empirical machine learning research. And that's a state of metric chasing where every publication seemingly beats the state of the art, and there's hundreds, maybe thousands of them being published. And that's what we like to call machine learning for accuracy's sake. There's three problems connected to this. For one, pure predictive performance in isolation is actually not a great metric for scientific progress here, because our metrics are not necessarily aligned with the impact that our research has on society. Publication bias is a problem because there's so many publications that beat the state of the art, and finally, due to these epsilon improvements on known benchmarking datasets, the community really doesn't trust positive results anymore. There's a great example from Roberts et al. 2021, where they examine over 2,000 machine learning models that detect or prognosticate the coronavirus, and they found none of them to be of any clinical use. Secondly, if there's a hyper focus on predictive performance, this really sets bad incentives for researchers, because they're incentivized to submit only these very specific papers that beat the state of the art. And then, of course, we're in this downward spiral where reviewers expect papers to beat the state of the art, and then researchers will only publish this even more, and so on and so on. It also emphasizes some of the confounding variables involved in research, like for example, in some subfields of machine learning, you're really only able to beat the state of the art with a good amount of computing resources. Finally, we believe that due to this current state, machine learning research has become increasingly inefficient. There's bound to be a bunch of parallel works simply because the research field is so big. It's fast paced, people try out a lot of stuff, and since the negative results are never revealed, even the interesting ones, people aren't able to build on top of those and might even repeat the same mistakes over and over and over again. Pre-registration is used in other fields to help alleviate some of these issues, but it hasn't taken off in machine learning research, we believe due to the fast-paced environment. So what can we as a community do to better embrace negative results? We think that special issues, special tracks, special workshops for negative results are really important. It creates a protected space to showcase important and relevant negative results, which could really help recalibrate the mindset of empirical machine learning research. There are some success stories in the field, like the I Can't Believe It's Not Better workshop at NERBS, and some others that we highlight in our paper. We think this should be implemented within subfields of machine learning, simply because of the size of the machine learning research community. There's only one or two venues a year where you can publish negative results. this will really not change that much. Another measure could be making a conscious effort to adapt the review process. This could be as simple as creating guidelines on how to handle negative results and what negative results are and what's important with negative results for reviewers. This could also be as complicated as revamping the whole review process for empirical machine learning publications. For example, implementing a two-step review process where you really only get to see the results of the experiments in the second step. You could also reevaluate certain criteria with respect to negative results. So for example, surprise factor and obviousness of the results are arguably more important for negative results than they are for positive results. There are other things like encouraging researchers to discuss negative results, incentivize replication studies, and many more that we highlight in the paper. Finally, we want to give some counterfactuals that we encountered, for example, in discussion with colleagues. We don't have time to go into the back and forth here and provide our counterfactuals, if you will, but we still want to highlight some of the important counterfactuals. One is that the publication of negative results actually lowers the overall quality of research in our field because we're not pushing the state of the art as much. Another one is knowing that a method doesn't work in a specific setting doesn't really have that much value. Knowing it does work in a specific setting is of higher value because we can then apply it in that setting. Another one is that if we pull the focus away from predictive performance by embracing negative results, there will be a new proxy for scientific worth, and we have the same problem all over again. And finally, many people believe that certain types of negative results will be treated unfairly and will be more likely to be published than others. This brings us to the end of our presentation. Thank you so much for your attention and for listening. We hope we could teaser you a little bit and now you want to read our paper. Please feel free to check it out. Here's the link to it. And do come see us at ICML and start a discussion with us because we do think that is the most important thing moving forward, talking about it.